right, so today we are going to talk about WAN technologies. When you take CIS-40B, you're going to have a couple of units on this again. 40B is really focused on routing and switching configuration. So the whole content of that class is going to give you a lot more practice in configuring routers and switches. If you are taking the 26 series with RCC, right, that one is really geared towards CCNA. They have a similar course, but it's not exactly that certification. So Cisco has its own routing and switching certification, now converted to CCNA completely. But you can look into specializing that. I think in the summer, I'm going to be working on cybersecurity engineer or firewall engineer certificate. And then maybe modifying the associate degree for the upcoming 2028, maybe for the associate degree, because now the job landscape has looked a little different. But today we're going to cover 3 chapters, so bear with me, right? It has some content with switching and routing, and then we're going to talk about WAN technology, which is your backbone to your network. So as we learned in the past, we talked about switches a lot, right? You have used Packet Tracer to be able to configure switches on your Packet Tracer, and some of you have probably practiced more. So we know that in the network, data is being sent as a packet. If you use multi-layer switch, you would see that being used as a router as well. So we usually use packet switching is a way that we can transmit data, but not in one bulk, breaking it up, and think of it like chunking it into different packets so that way we can send it and it's not going to reduce the performance of our network. And this is how we can move data into and data out of our network, is to use packet switching. And so typically you would have a routers that's going to be routing, and you would use not just a router, multiple routers, and we would be dynamically using the routes to be able to send data from source to destination. So in that sense, we need to know what packet switching means. It's just a process that we can chunk the data into different packets and be able to route it into and out of the network. And so when you are sending the packets from router to router, typically the router would either determine how is it going to get it to the destination as quick as possible, or it would follow the path that is already pre-configured by the administrator. So let's say that you take the same route from work to school every day. That's going to be a static route, right? We talked about that before. Or we can look on Google Map and try to find the fastest way to get from point A to point B, depending on the traffic of that day, depending on whether we have road constructions or not, right? Or if you have time and gas to be able to travel more or less miles. So packet switching is common. And now what we see is that it's not relying on the actual packet size or your payload, right? It's a way that we can assemble the packet and be able to have different data groups to be able to send it through. So in the case, if you're getting a breach, they're not just pulling one packet, right? One packet is going to give them one piece of information compared to if your payload is stored only in one packet. So we want to be able to utilize packet switching so that way it can ultimately maintain the network bandwidth and give us a little bit more better performance. So let me see, hold on a second. So in question 1, it says, what are the main differences between packet switching and circuit switching? So in the second part of the first part of the notes, it talks about circuit switching is a way that we can open the circuit. This is what you see that happened historically, right? When you have telephone networks, which is analog, and the way that they did that was to open the circuit by simply changing the switch or removing a certain wire so that way that circuit becomes available. So you often know that when you pick up a payphone, some of you probably don't experience this because you've never seen a payphone before, right? But in the movies, you might see a payphone where people put coins in the phone, right? After they pick it up, and they would hear dial tone, right? Tone, like a tone that you would hear so that way you can start pressing the number. This allows this tells the user, the person who's calling, that that circuit is open. Now I can press the number so that way it can start initializing that call. So in the past, what we see is that we would open that circuit so that way we can make a call. And throughout that time, you would be able to hear analog voice, right? Your voice comes as analog waves. And so that way, in this case, it becomes a little bit more efficient, but in the sense that you are relying on that open circuit. So if any chance that circuit is disrupted or terminated, then you are not going to have the communication. So there's positive and negative side to both of these. So it talks about how it would be less efficient from packet switching to use circuit switching, which is what we've seen from the 1920s up until today, right? But because it doesn't really create any kind of permanent path. I'm sorry, it does create a permanent path, but it doesn't have a way that we can stream the data across. Now, every time that I need to reconnect, I have to reestablish that circuit, right? I have to reopen that circuit again. So it becomes not efficient, because in computing, anytime that you repeat the process, ideally we want to streamline that process, right? As you know, that we buffer and cache and all of those things, so we don't have to reestablish every time. So in the past, in the 90s and early 2000s, when people make a phone call and they hang up and then they need to make the same phone call to the same number, they would need to pick up the phone and reopen that circuit again. So if you're looking at dial-up modem that was functioning with circuit switching, right? It wasn't ideal. And then eventually we transitioned completely to packet switching. So circuit open for circuit switching, and then packet switching is a way that we can have each packet store a certain amount of data, and we can send a group of packets across the routers to be able to get to the destination. Any question? Yeah. So if you hang up the phone back then, it just stops the communication. So back in the day, in the dial-up modem, right, it has to have that circuit open so that way you can have, and it will dial the number for your destination server, and then it will connect and you hear that buzzing noise like the AOL days, okay? And then once that's established, and then when you sign off AOL or a service like Yahoo, whatever, then it terminates that circuit. It ends that circuit. But also back in the day when you're using your dial-up, you couldn't use your phone at the same time. It will occupy that line because that circuit is specifically open for that one dial-up session. Okay? So then we're not using technology efficiently because you can only communicate for that time and nothing else, right? You cannot make phone call. And then eventually they were able to implement the technology so that way you can call in, right? So we utilize different channel for your circuit to be able to call and be able to do a dial-up at the same time. Any other question? Okay, so before we talked about X25, make sure we review this information for our final exam and quiz, right? So X25 is a way that we would use packet switch network, and it uses a technology called packet assembler and disassembler called PAD. So pad is then connected to a serial port. Why a serial port? Well, that was the technology back then. Bless you.
Thank you.
So think of serial communication. You guys saw this when you configure your PuTTY last time, right? When you did the lab. When we use serial port like COM for communication, typically your data travels slower. Okay? It's like gathering your bucket of water one drop at a time for cereal compared to if we are using other type of ports. So the technology back then was that we would use serial port and it would use the RS 232. If you study for A+, they might have talked about this. Okay. So typically the cable is a little different, right? It looks like a VGA cable, right? It's a D type, and you would have the two screws. I will pull that from the back to kind of show you shortly, maybe if I can have access to it. So it's gonna send one bit at a time, and therefore it's a little bit slower than what you see with your USB or your Ethernet connection now. That's converted with the crossover Ethernet cable. And you would use this for the first 3 layers of the OSI model, right? Communication at bit, at frame, and then at packet level. So the transfer rate for this is 2 megabit per second, and that's a big ordeal back then, right? Because if you are typically for the consumer side, if you're using dial-up, it's only at most 128 kilobit per second, which is a fraction of that. Or if you're using earlier dial-up, which is 64 kilobit per second, which is also a very small fraction of that. So for each of the line, we're still using analog, so it needs to encapsulate analog signal to digital. And it's transferred 2 megabit per second. Now, so in the past, when we install frame relay, we would use the digital version of X25, which gives us a tremendous boost in our speed and we can implement quality of service. We talked about QoS before, right? Prioritizing traffic, being able to, delegate and be able to look at some of the feature that we can implement so that way we can have better bandwidth. And so when packets and frames are sent in the switch network at the higher level of protocol, like your TCP/IP, before TCP/IP, you would see IPX and SPX that was used with Oracle technology. It would then be able to route the frames and the packets to the destination. So frame relay was something that was in older technology, and it would use X25, the digital version of it, for 50 megabit per second, which is not bad at all, right? For the time. Okay. So in question 2, it asks you what technology is used in X25 switching network? What is the transfer rate of X25? It uses PAD or PAD, packet assembler disassembler. So that means that it has to assemble the packet, right? If you're looking at the OSI layer 2 is in charge of frame. Frame typically is a way that it can pinpoint. It would set up the data for the next level, which is your packet, but it also is used so that way we can move it across the network by switching. So at layer 2, right, it needs to be able to assemble. Think of it like how it frames the data, right? It would be able to put some header information about the frame, which systems, which MAC address before the IP, right? IP is layer 3. And then when it gets to the switch level, it needs to disassemble it. So that means that it needs to convert it back, right? Looking at the frame saying, oh, that's the destination system. This is how it's going to be able to give the data to that system. So PAD was used for connection in X25. And then PAD is also connecting at the serial port using RS-232 compliant cable. And then for number 3, it says, what layers of the OSI model does frame relay use, and what is its transfer rate? So frame relay, it uses the digital X25. It is operating at layer 1 and layer 2 of the OSI model. So whenever you see the term frame, you know that it's only going to be up to layer 2, right? If it uses the X25 digital, it might go up to be able to route, but a lot of times when you hear the term frame, you know that's functioning at layer 2. In order for it to frame, it needs to connect at bit level. So 1 and 2 is going to be for the layers for number 3. And the transfer rate is up to 50 megabit per second if you're using digital X25 and QoS, right? So we want to maximize the bandwidth by using quality of service. We talked about that a couple weeks back. Okay. So in the next part, it's going to talk about your SONET network, which is your optical network. This is what you see with fiber optic, okay? Fiber optic can be common. It is common. I think now most of the expansion, there's a huge grant for the nation to really bring fiber optic to the community. I think some state, they were able to capitalize on that, especially in the rural area. I know that for most of the newer neighborhood, fiber optic is being installed. And then at the home, the Ethernet connection is available in the wall, right, as a socket to be able to communicate. So for the next question, it asks you what protocols are used to transfer multiple digital bit streams synchronously, that's the key word, over the optical fiber using laser or LED. And you would know that this is a synchronous optical networking, which is known as SONET. Okay. And synchronous digital hierarchy, which is SDH. So when we say the term synchronous, it means that it's together, okay? When you have asynchronous, you might have different format, meaning that you might have a send and receive at different time. So synchronous just means that the signals are going to be together. So let's flip back here. I'll show you where you can find this in the notes. So it starts with SONET on page 2. And by definition, you can find that here. So it uses the electrical interface, and it's before this, it was PDH system to be able to transfer this over the telephone line for your data traffic. So as you know, fiber optic been around for a long time. It's just became very commonly installed because the technology is affordable to the consumer and also to the common business. Okay. Back in the day, the government might have fiber optic and some of the elite business like Google and Microsoft for their data center, but you don't see that as a common technology because it was very expensive. So nowadays, if you want an engineer to come out and dig a line, you typically pay $6,000 to $8,000 for that job. Right? They'll install a fiber box. We've done that for Parkside. And then be able to utilize that for the backbone to your network. So it's not ideal to put fiber in every room. It's just not cost efficient. So what we do is we install the fiber lines to our main network where our routers, some of our main switches, right, where our distribution switches actually sit. So it goes to your server room or your data center where the main, right? So everybody funnels to that backbone. And think of it like you don't take highway to go to your home. You take small road and then you jump on the freeway or the highway to get from city to city. So that's the point, is we want to travel higher speed from router to router. right? So ultimately, the internet is really made of that. The higher, the super highway speed, where the routers are connecting. But when it gets to the smaller network, the private network, you actually handling that even with routing on a lower scale. So that way it becomes more efficient. So here it tells you that your SONET or your SDH allows you to simultaneously transport at different circuit. So ultimately, it's still using electrical circuit. Everything uses electrical circuit in computing, right? You know that the computer where you're sitting, it's called integrated circuit, right? All of your boards, all of your devices talk at electrical signal level, right? So as we can see, we have to implement a technology where it is the speed of light, right? To be able to get you that faster communication, which is what you see today. Instantaneously, you're going to get some response if you send a request. So back then, what they did was they implemented this for ATM connection. No, this is not your ATM machines that you withdraw cash and deposit, right? It's just the technology that you use for your network, which allows us to implement Ethernet standards 802.3. So if you're looking at the larger business, take, for example, Bank of America. I had a friend that managed their mainframe. So back in the day, right, your data centers consist of mainframes. These are big server systems that has, all your account information, all your updates, etc. And it would use ATM connection to be able to go from the one branch to another branch and HQ to branches. And with that, they would implement fiber optic, right? So I told you guys the story about Google. Google were tax-free for a long period, and then City of San Francisco said, time's up, right? You already got your startup deal, tax break. Now you're going to have to pay tax. So Google said, well, if our data center is on land, we're going to have to probably pay for the amount of money that we're going to make for the profit, right? For that data center. So they put it on a ship and they put it into the bay. And the bay, San Francisco Bay, is part of the open water. And as you know, some of you might be in the Navy or were in the Navy before. You've heard of open water. You cannot tax things that are on open water because it's not on land. And so what they did was they implemented fiber optics in order to support communication to this ship that stores racks and servers and things like that. It still exists today, right? But they still have Mountain View location and other campuses, but it gives them a little bit less tax, right? So that's an innovative way to be able to integrate this, and it's been there for a long time. Okay, so any question? Okay, so let's talk about the OC rate. So let's answer the question first, and then we'll come back to the table. So what is the transfer rate for OC1? Think of this as just a standard, right? One more thing you're going to have to remember, because this industry, you're going to have to remember acronyms and numbers, right? So OC1, it transfer at 51.48 megabit per second. Roughly close to what you see with frame relay, okay? X25 digital. Okay, where can I find this information? It's on page 3. So optical carrier is what's known as OC, right? And this is a standard that you use for SONET. So if you were saying, all you have to do is remember the rate for OC1, and you will be able to calculate everything else. Why? Because simply it's a multiplier. So if I know that OC1 is about 51.5 megabit per second, I would then be able to calculate OC3, because you simply take the 3 and times the rate. Understand? So if you remember OC1, then you would know OC3 or OC9 or OC18. Okay? For those of you who aspire to be fiber optic technician, you have to remember these things. Okay. So as you can see here, right, we simply take the value and multiply it by the OC1, the multiplier right here. So if you have OC12, it's 12 times OC1. That's what I put as an example right here. Okay. Remember that this is an optical carrier standard. That's for OC. So come back to that question. I would be able to remember it's about 51.84 megabit per second for OC1. And then earlier we answered some question about synchronous. So the basic unit for the frame in SDH, which is known as STM1, which stands for Synchronous Transport Module Level 1. And this operates at 155.5 megabit per second. Whereas if you're looking at OC standard, right, so it is at a third of that. Okay. So that means that one STM1 is going to be almost equivalent to the OC3. And if you're using your STS3C, this is going to be Synchronous Transport Signal 3 concatenated. This is specifically for fiber optic, right? All of these things are related to fiber optic. It would use an optical carrier 3, so it's 3 of the ST1. So just like what we learned about the OC, when you're looking at the number right here, it's a multiplier of the STM1. And so it's 3 times. So that means that it's still piggyback on the standard. Okay. And then it talks about how it's not designated to a standard for the physical layer. So does Network Plus, will they ask you about fiber optic? Sometimes you randomly getting the questions. A lot of the times they would implement it where you would need to know. And fiber optic is regularly used. Okay, so go over here, read this section. It talks about the transfer rate or how it would be equivalent to, specific standard. So how do they install this, right? They would be able to implement it. So here my network might be Ethernet, and I need to implement that, right? So you will contact your service provider like AT&T, Spectrum, etc. And then they have the fiber line. So now, as you know, in California, they control the monopoly in communication, so you cannot have one service provider across all the city, right? So they divide up the zone for a specific service provider. And in some cases, Moreno Valley, for example, as a city, you might live in an area that doesn't have fiber optic integration yet, right? So you can't have fiber optic to your street. So technically, I have fiber optic, but it's to my street. And then from that green box on my street to my home, it's still a cable line. So in my garage, I still have a coax that's running to my modem, right? So it's kind of like saying, I buy a sport car, but I can only drive it 50 miles per hour. So still, you're still paying for the backbone line to your street. So when it's still going to give you a better throughput than what you see. So in a business environment, they're still going to be able to integrate that, but then you're going to have to specifically identify what kind of standard that you would need. Is it 3 times? Are we going to use OC3? Or do we only need a certain speed? So how do I determine that? Well, it's really how much you use your network and kind of data that's being passed. in today's world, right? So if you're comparing a network like Twitch, they're streaming and they need like more instantaneous response compared to a network like a school where, so there's different goal and objective in every network. So it doesn't make sense for everybody to be specifically at a certain standard and everybody implemented fiber everywhere, right? But if you're going from one building to the next building, like in this campus, you need to pull fiber in order to support the higher data throughput. Okay, so go through. It talks about this, and then in the next part, it talks about wavelength division multiplexing. We already learned about multiplexing in the past, right? So what's multiplex? Duplex is when I can send and receive at the same time, right? Multiplex is what? No, crickets.
Send and receive multiple. And send and receive multiple.
Yeah, I'm able to, like, if you send me, all of you send me email, right? I'm able to respond to all of your email simultaneously, right? That's multiplexing. So some systems, like routers, are able to multiplex. And where most of your system should be able to do full duplex, right? Send and receive all simultaneously. So in that case, you see fiber optic communication, what it does, it uses wavelength division multiplexing. Why wavelength? Because ultimately it's still optical light waves, okay? Either LED or laser, okay? So it talks about bidirectional communication in strand of fiber. Now, how is that different between the laser and the LED? Which is better? I think we talked about this in the past, right? And so if you're looking at the fiber cable itself, if it's for LED, it's the core inside is made differently compared to the laser, right? So it uses a different source of light. And so with that, it's able to do the division of duplexing, and it's multiplying that. That's called a multiplexing, okay? So that means that I'm able to send and receive quicker compared to a full duplex, like in the case of Ethernet. And then you have the normal and the coarse and the dense. So the normal WDM, it uses two normal wavelengths. So instead of one wavelength, it uses two in one fiber strand. Whereas the coarse, it uses 16 channel for the transmission that can go 120 kilometer. That's a huge difference, because if you're looking at, like, even with coax or Ethernet, let's take Ethernet for example, right? Ethernet is going to limit you to approximately at most 120 meter. So most of the admin, they would want to go 100 meter, because the farther you are from the source, the less signal you're going to get, right? And then your cable is going to be limited. So the media, so if you're using different type of the wavelength, right? Multiplexing, you are able to capitalize on how far you can go. In the case that if, let's say I own like Cisco, right? If you ever been to San Jose, California, you go to Cisco, it's a whole street for their company. It's like, they call it a campus. It's not even like one building, right? Because it's like 10 or 12 buildings. And so each building is huge, and they have to connect everything together. So that means I have to run fiber across my campus in order to accommodate my company who sells communication technology. And the same thing with Broadcom and other companies, right? So when you look at coarse, simply it's implementing 16 channel, and that means that it's able to transfer massive amount of data farther, right? And so when you do the coarse, that means that the width, the radius of your strand is going to be slightly different. Okay, so that's just different type, and then also the bands. Okay, like I said, this specific things, if you want to go for fiber optic certification, you're probably gonna have to know the specific because that's what you're gonna be working with. But just know so that way in the case if you apply for a job at a data center where you have to install fiber optic or you work with fiber optic, you would know what they're talking about to get the job, right? And then you also have passive where it does separate wavelengths. And then also dense, the speed is because of the spacing. So for the dense division multiplexing, what you see is that it's gonna be different band here, okay? So just like wireless, you're gonna have different band for the communication in fiber optic, different type and different wavelengths. Okay, so for 6, what are the 3 types of wavelength division multiplexing? We need to know that there's normal, which is your NWDM. There's coarse, which is CWDM, which uses 16 channel. And then your dense, which is DWDM. And token ring technology has been around for a long time. You might have learned this in another class. If you take 40B, we're going to repeat some of the information. But the way that we do is that system pass token from a ramp, right? It's kind of like, you ever play a game where you have people pass around the object. When you get the object, it's your turn to give an answer or talk, right? So it's like that. When the system passed the token to specific system, and it was just a better way for us to have a little bit more security back in the day. But token ring technology is implemented in communication in different ways. So in a fiber distributed data interface, your FDDI, you have 2 rings, primary and secondary. This is used to pass the token in opposite directions. So let's think about it. Let's say that you hang out with a group of friends and you divide the people up. There's 1 ring on the outside. You tell your friends, let's pass a bottle right to the right. Okay? And it's gonna go from one person to the next until it comes back to the original location, the first person. Then on the inner circle, you have another group of friends and you're gonna pass the bottle to the left. Right? So this is a way that we can implement data distribution in a circular manner by implementing 2 rings. The first ring to go to the right and the other ring to go to the left. Okay? So that means that we simultaneously are able to send and receive through the tokens on 1 ring and another ring. Any question? Sorry, let me get down to. So if you look at ATM SONET, when you look at the fiber distribution box, it's gonna look like this. Okay, that's an image of it, and they are fiber strands. There's different grade of fiber and different type of fiber, as you know. And so it's gonna then terminate at the box, which so if you want to install fiber, you're gonna have a fiber box. These fiber connection is gonna funnel to your box. Then your box is gonna have a switch, a distribution switch that's gonna convert that signal to your Ethernet signal. That's how we can incorporate this in our server room or our server rack. And then on that rack, you would see that the switches is then gonna be receiving with the Ethernet Now, some routers, you can connect fiber line code directly to it, depending on the routers that you have. Then other routers, if you have an older router that only use like a serial cable or, a Ethernet cable, fast Ethernet, you have to be able to convert it through the box. So your FDDI, which is your standard for your data transmission into your private network. So think about that cable box. That's a way that we can interface with the fiber into our physical ref. Okay? And then the primary ring and so the inner ring, you can see it this way. And then earlier there was mention about ATM. Make sure we know the terminology. Asynchronous transfer mode is your ATM, not your ATM machine. It is a way that we switch communication asynchronously using time division. So when we say asynchronous, not together. Okay, synchronous means together. Asynchronous is not together. So a transfer mode is using cell and it creates a virtual circuit. So when I started entering the field, ATM is abundant, just like how you are seeing fiber optic today, right? And frame relay, that was like every business, they want to upgrade to a certain type of network. And so will you see this still? There might be some old part of the network in some businesses that have it. And so you just kind of need to know the difference. Your ABR, your CBR, and your UBR. So it talks about available bit rate, constant bit rate, which is a fixed bit, or unspecified bit rate, which is unknown. Okay. So that's a type of service. And then the fourth, I only mentioned 3 here, but those are the main services that you see. Okay, let's go through and answer the next few questions. So let me move 7 down. We got 6, right? Okay. So for number 8, it says, what is the size of data packets being passed in ATM or asynchronous transfer mode? Your data packets are referred as cells, and they are fixed length. Typically, they are 53 bytes. When you did the Wireshark lab, you were looking at your payload size, right? Most of your payload size is in megabytes. And it's the size of your data is going to be limited to the network medium and the network technology, the services that you use. Guaranteed. Okay. It's kind of like how you can buy a Porsche. Okay. In United States, you can only drive your Porsche to a certain miles per hour because there's regulation, right? You can drive it really fast, but you can get arrested for high speed. Okay. But in other part of the world, you can get your sport car, like a Porsche or a Corvette, whatever you like, and drive it in a different speed. Like in Europe, some part of Europe, you're able to take it as fast as you want. There's no speed limit, right? I know there's some part in Nevada that you can do that. So depending on the state, depending on the country. And so with that, we can say that if you are implementing network technology, it's really governed by the number one, the cable, the appliance, and the service that you use for that design in the network. Okay. And even in fiber optic itself, the type of fiber and how you implement that with your FDDI can yield different transfer rate for sure. So when people say, oh, I have fiber service, that kind of generalize and have an assumption that they do have fast throughput. But does it really mean that they have a specific type, certain carrier? There's so much more in fiber than you know, right? So in this class, it's supposed to give you the breakdown. You can understand the difference in that. Even back in the day, we implemented ATM, and ATM give you a certain speed faster than in some slow cases that you see today. So let's talk about lease lines. So there are two types of lease line, which is the next section of your notes. It talks about internet technologies and how are they used. So lease line were common back in the day, and in some cases in different part of the world, they still might have the tier. So TX and E carriers are the types of lease line. TX were used in the United States, Japan, and Australia. And the E carrier is used in Europe. Just remember E for Europe. Okay, TX, I always remember that for Texas, and that's the United States. It's just sometimes I have to come up with different ways to remember. But anyway, the T is for US, Japan, and Australia. And then the E is for Europe, Mexico, and Latin America. Okay? And then the fractional carrier can be leased for a fraction of cost and the speed to transmit the voice and the data images. And you can also lease line for a period of time. Some of you might not remember the long distance charges that you have to, so when you make a call, right, if it's depending on who you call, that you have to pay for, but it's kind of like paying for data rate these days. So let's say that somebody built a road for you to drive on, but you want to rent that road from 8 a.m. to 5 p.m. And that's what we do for the lease time. You can lease it for a period of time for your business operation and then free up that road for another company that operates at night. We can also lease it for a year, right? Kind of like data center today. We can put virtual machines on someone else's server racks, and then we just pay the contract year to year to year. So lease line is a way that we can use somebody else's communication. And in United States, we would use the TX, right? And so you just pay for the cost. So fractional T-line, fractional carrier allows you to pay less. So instead of paying for the, your private road for the year, you can pay for half of it. Like I use it half of a day, because my company only operates 8 to 5. And then everything else at night, you can rent it out to another company that uses from whatever, right? Now, like the government, they would have not a lease line, they would have their own one for privacy purposes, right? So if you're talking about like agencies, they would have dedicated lines. So that's the difference between a lease line and a regular line. So they own the road, basically. They own that communication line. Any question? Okay, so here's the breakdown. You're going to need to know how to calculate this for your final exam. If you're looking at a tier 1, a T1, it has 24 channel. And each channel, because remember back then, right, that was a modem speed. 24, we would take that and we would multiply. That's a multiplier, 64 kilobit per second. That's going to yield about 1.5 megabit per second. I think we talked about this before. So each of your 64 kilobit per second channel, this is known as your DS0. And so when you're using a tier 1 or a T1, you're going to have 24 DSO, which is equivalent to 1 DS1. That's the next level. Okay. So when people install tier 1, they're going to transfer at max 1.5 megabit per second. You look at this and you laugh. You're like, oh, my home internet is like 20 times that, right? And I'm paying for cable, not even Ethernet. I mean, even fiber, right? So But this is what most business go for because it's gonna be the cheapest at the lowest. You pay for what you get, basically. So this is a lease line. Basically, I rent that communication line for a period of time if it's fractional, or could be a year full use. And that's the highest. So I had function as an admin for a company that used tier 1. And every time it's like the peak period, it just bottles net, right? Because they're just limited to this. It's kind of like all the cars are on the freeway at the same time, and everybody's trying to go like 80 miles per hour, but nobody can because it's congested. So you have bottleneck the way that the network was designed. So they upgraded to 3 times that to a tier 1C. And then some business, when they have more money, they would go with a higher tier. So you simply, if you look, right, this is going to be approximately double from tier 1 to T1C, and then double that to go to T2. And it really depends on the channel. So in Europe, though, Europe, Mexico, and South America, you have 30 data channel and 2 signaling channel. And so you would take 30 times 64 and 2 times 64, you get higher speed in Europe and Latin America, okay, at 2.0 megabit per second. And so if you go with the E2 carrier, it's 16 times T1. And so if you compare, right, a T2 to an E2, oh man, Europe is much faster. And it's still happening today in communication in different parts of the world because of the regulation that we have in North America and some part of the world. Okay. Also, the limitations with service provider installation and integration, etc. But a lot of it has to do with rules that were set on how communication can be integrated. And this is what you see. Why is some part of the world have better smartphone? Why did they roll 5G a few years before we did? Well, because of this, the regulation in communication on the landline, which relates to cell tower and everything else that you use. Okay. So we talked about TX and E for the lease line. And then for number 10, it says, how is channel service unit, data service unit? We talked about this before, your CSU and DSU used in an organization, in a business. We would use the CSU and DSU to handle T1 or T3 links. So that way data can be sent between service provider and router. Remember that your router is your gateway to your private network. So every business would have a router, whether it's wireless or a wired router, and that router would be connected to your service provider, Spectrum, Frontier, AT&T, or other, right? And so back then when we're using, in the United States, if we're using T1 or T3, we would use the CSU and the DSU to be able to send data. Bless you. 1 is for channel. It has to establish the channel for that circuit. 2, once that channel, that communication is open, you would then send the data. And that's how it worked. And this would help with interference because when you have a lot of communication media together, right, you would have interference, loss of signal or interfering signal, which degrades your signal. Okay, so I would challenge you today, go home and find your demarcation, or if you live in an apartment, you can too. Go around the building. Don't do it late at night because you can tell. But so demarcation is important because if you're going to become a cable installer, you're going to need to know, right? Some people, most of the residential neighborhoods, your demarcation is where? So if they need to run a cable to your house from the street, where does it go? To your garage, right? Why is it to your garage? Because that's where most of your electrical operation can take place, or on the side of the house where your main switch to turn off power and on. But ultimately, that's just the process and the practice. So what is the primary difference between the demarcation and a smart jack? Demarcation point is where the service provider equipment connects to the building, which is used to determine the responsibility of the maintenance and repair. So if it's attached to your building, guess who's responsible for it? If it's their equipment, they come out and they troubleshoot the equipment. But if anything else connecting to it, like electrical, not their problem, right? Now, when you go to your neighborhood, you might see, I know my neighborhood, I don't know about the newer neighborhood, they might have a different way to control the communication to the street. If you drive around your street, you would see these little green covered boxes around Moreno Valley, right? They're like a foot, 2 feet tall. And usually it's green. That's where all the communication for that street goes. Okay? When they go to the box, they adjust the speed, and that's how you can, that they can control it at that box. Okay? Now, so how does it go from one part of the city to another city? And if you drive on an on-ramp on a windy day, you might see that like mulch and dirt get blown, and you see this, like maybe, I want to say 10 by 13 covering. It's like a rectangle. And then underneath that is actually ladders to go down, and it would lead to the tunnel for a lot of the communication company. All the manhole leads to a tunnel for that specific own company. So, and it will be labeled on the manhole. So that's really the responsibility of the service provider. The manhole that they own, which has the line into their switches. And then, but to your house and your business, that's a demarcation point. So if you live in an apartment, you go around the building, right near the electrical, usually that's where the insulation for your cable gets pulled in. And then it will get pulled into each unit. Some of the newer apartment building would have fiber to their building. And then inside each apartment unit would have Ethernet breakdown for different rooms. And in most homes, you might still have coaxial. Why coaxial? Because it's the cheapest. As you know, copper is easy to run, and it doesn't degrade as fast as some of the other type of copper, which if you're using thicknet. But it doesn't make sense to run fiber optic to every single apartment unit. They would just run it to a specific building, and then from there they would break it down with coaxial or Ethernet. So you would have fiber termination at the demarcation. And then your smart jack is also a demarcation, but it uses your CSU and a DSU. Why this? As you answer the last one, it would help with interference. It reduces the interference, so it converts the signal and regenerate it. So it has a repeater capability, right? And it also can check so it does diagnostic and troubleshooting. So in the case if you have signal loss or something, it will be able to recover from that. So it would be better to do a smart jack than just a demarcation. Understand? Okay, so, and of course, this costs more. Any question? Yeah. No, demarcation is just a location where your communication is attached to your building or your home. Like if you live in a home, it will be to your garage. Okay. If you live in an apartment building, it might be like at a corner or in the back near the wall. Usually they put it near also the electrical maintenance. And you want this to be protected, okay? So we don't want people to go and tamper and just start yanking cables and then you're in trouble. So usually they run conduit. And so that way the cable is protected with weather and also from cutting. So if you have fiber to the building, those lines is gonna go to a fiber box, which is probably covered in a metal unit or something like that. Either it's standalone right near the building or it's attached to the building. Okay, so at your home, go check your garage. There probably is something connecting there, and then from there they tap it into your living room, your bedrooms, etc. Okay, so let's talk about DSL. Anybody still use DSL?
They still got an old DSL modem somewhere.
Most people upgraded around here in California because, if you live in the main city, you probably don't need DSL anymore. But if you live out in the yonder, right? So like past Ukaipa, like Barstow, or maybe in the hills, right? If you live in the canyon and if you don't have options to fiber, I think usually if they have a cell tower, they will probably have a fiber line somewhere near there. But you have a lot of options with communication these days. So I have a family member that lives in the rural part of Washington State. She lives right across from Columbia River. It's beautiful. But to drive to her house, you gotta go up the hill in the woods for like 2 miles, and it has its own hill, right? So with that, they're still using DSL. And then they had contacted the service provider nearby or the same service provider, and they said, well, we can't just dig a line just for you. So if your neighborhood, all your neighbors are willing to pitch in, everybody pitch in a few $1,000s, you can pay us and then we'll come out and dig a fiber line and tap it for you. Right. So the primary difference between your asymmetric digital subscriber line, your ADSL, and your SDSL is that ADSL has different download and upload speed. So I want to say 10 years ago when people subscribed to DSL, sometimes you would see a package, right? Like you can upload at 10 megabit per second, but you can download at 20 megabit per second. That's an ASDSL, asynchronous. It's not together, right? Different speed. Whereas SDSL, download and upload speed are the same. Okay. So if you know people who are still subscribing to DSL, you should tell them to look, right? And then sometimes they only offer that type of service. So sometimes you get 2 packages by the service provider and you have an option. This is cheaper, right? So if you're gaming or if you download or upload a lot, you're sharing files a lot, then you might need SDSL. Question? Okay, so what type of devices are used for satellite? So, do you need more explanation about digital subscriber line? So, as you heard, right, we would have a modem for DSL, of course, because it needs to convert. Also, a lot of them are still using phone line or analog line. So that's why it's limiting to the speed that you see. And then that's different than your cable service, which use coaxial. And that you typically is roughly a little bit higher in speed. So many of you, if you have cable at home, through Spectrum or whatnot, right? You can get TV, internet all together in one package or a separate package. That's up to you. Typically, you're limited to also the type of cable that they use. So that's a copper coax base. And then it gives you the voice over IP, which uses digital signal. Now, satellite, well, is that better? Well, also in some rural area, they cannot get DSL, then they have to use satellite. So what's the downside about satellite, you think? You guys heard, I'm sure. So I saw quite a few social media video about people advertising Elon Musk and other people's technology about satellite. Like everybody practically now, anybody famous can launch it. So having a satellite up, and people are saying, oh, I can go to any part of the world in the top of the mountains, on bottom of the mountain, I can still stream using this specific service because the satellite is still available. Do you think that's true? So let's say that I can go to another country and I can still use the satellite service. I have full internet access, right? I won't have any disruption. That's good. And it's gonna run me roughly the same amount of money that I would pay for something like fiber per month. But I'm able to travel and take it with me. So the downside about satellite is line of sight. You guys hear about satellite being out? Sure. It's a flying device orbit around the Earth, right? So the way that they can make it commonly available, how? They just have more satellites. It's a network of satellites, right? So I had this discussion with my husband in the car the other day because he's like, why don't we just get that service? We can take it with us. And I said, yeah, that's if nothing happens to the satellite. So let's say that you and I travel to India and we're trying to have communication using the internet because that's what our phone uses the app. If our satellite is not accessible, you're done, right? So that means that you are still going to be limited to the line of sight. On a cloudy day, some satellite cannot be seen. You guys probably heard of this. So we have the Makerspace or the iMake Innovation Center bus. Before, we paid $7,000 a month for a satellite system. Very, very expensive to use that dedicated line. First day that I have been on the bus when we trying to launch and go to an elementary school, we park it between the building. No satellite signals. So when you're around large tree and large object, guess what happens? You have disruption because it bounces off the large object. So your satellite is going to be limited, right? And so using the satellite, you are going to be connected to the modem. So if you use satellite TV, I've seen a lot of it still. I drive around my neighborhood, I see the dishes on their roof. Okay. They use it for phone, internet, and TV. A lot of people still use it. You're going to use 2 modems to connect. Most of the time, sometimes company now that integrate it with one. But it would be able to provide the service for the communication. So there's limitation with satellite, right? And in the case where you have no choice, that's the only thing. So I was talking to my student, and he said, you know, I used to live in Mexico. My family lives in a ranch. And when I'm there, because he goes there a few times a year, he tells me that he has no choice but to use satellites because that's the only thing that they have out there. Okay. Even later on, some part of the town has DSL, but they don't have the lines to it. So until today, you still see limitation in communication in different parts of the world. Okay. I will maybe take 14 down. Are we okay with 13? Any question? So as you see, the more you learn in this class, every time you just need to be aware, right? Drive around your neighborhood, you're like, oh, I know what kind of technology they have, right? Oh, I know this, right? So communication. So ultimately, I think eventually we're going to put a lot of things underground because even electrical wire, because, you know, they say that that's probably better for people's health and also just the maintenance overall. But I think still in the United States, you're going to still see a lot of communication line and electrical line being passed. You see, every time we have windstorm in California, they worry about that, right? Because if it takes out power, guess what happened? Nothing goes through. You cannot have business. People cannot pump gas. all kinds of chaos. So if you don't have backup power, you're limited. And this is why that's such a big thing in security for us is the grid. Okay, the mobile networks. Let's start with 2G. So 2G is an example of GSM, and 3G is an example of CDMA. I think we talked a little bit about this when we talked about mobile networks a couple weeks back. 3G is things in the past, right? If you have 3G, you can use 3G devices for communication, just like how you have 5G now. So what happens if I have a 4G device, right? Just like wireless, you have to be on the same standard, because if you're on a slower standard, you're just going to be traveling at that speed. So let's say that you're allowed to go on the highway with your bicycle, not a motorized bicycle, a bicycle. The fastest you can go is probably roughly about 20 something miles per hour, right? That's for a biker, consistently biking. Okay? So that's like having a 4G phone on a 5G network. It's like the fastest you can go is the speed of your bike. The fastest you can go is the speed of your phone. It's 4G. 4 gigahertz. Where you can go 5G, which is much better. That's why when they upgrade the technology, you have to upgrade your device to optimize and maximize your speed. And that's the practice in networking. But we don't upgrade things right away, right? People are going to slowly upgrade because you want to make sure that the thing works, what kind of phone, because a lot of the time the beginning technology can have problems. So people will wait and then they finally upgrade. Sorry. Let me see if I miss anything real quick. Okay, so in the notes, it gives you some picture about devices, right? And then satellite and cellular network. This is on page 10. So GSM stands for Global System Mobile Communication. GSM was popular, like if you use T-Mobile, AT&T, you would back then you would use GSM. 2G replaces 1G and then eventually 3G. You know that a lot different part of the world they rolled 3G before we did. And the GSM phone uses SIM-based technology. So it has your identity modules implemented. And then CDMA, that was integrated, for second and third generation, and then also LTE and 4G, which gives you up to 300 megabit per second. I remember when 5G first came out, a lot of people were like, oh, there's some part of LA. You can actually use your 5G phone there, right? But now it's everywhere. So you can see it on your phone when you're in a different part of the country or the world. If you're only on 4G, your phone will tell you you're on 4G, but you have 5G phone. Like, so when I was in Thailand, some part of Thailand, full 5G, right? So I could use my app, and then other part of Thailand, it was like 4G only. But I mean, it was still okay. So LTE, long-term division, long-term evolution. And then if you have like, global services with like T-Mobile or Verizon, you're able to use because it just convert to that network. You just got to be careful though, because in some part, even when you're using that, they would then charge you roaming for data in the case that you cross over that circumference of service. Okay. Explain why we should not upgrade production system first. Because failure to upgrade can cause disruption in operation. And so we should test the upgrade on standalone system and gradually deploy the network. So if I have an enterprise network, like let's say I have different region or different branches, I would roll the deployment slowly, right? So when you work on this kind of project for networking, you would have different phases. Like let's say phase 1, we're gonna go southwest, right? California gets upgraded first, and then we're gonna roll to the Midwest, and then we're gonna roll. So depending on the company on how, but before that, we need to make sure that we test it. And so how do we test it? We can simulate it. We can, put together a small network and see. But when you upgrade networks, a lot of times, so when we upgrade software and hardware, we usually also need to upgrade. And so when you upgrade the network, that means that you might replace routers and switches, right? You also upgrade services with those things because newer system might accommodate new services. So usually when we upgrade, typically it's both hardware and software. So hardware configuration, right? And then you also need to train people before you upgrade too. That's important. So that way, they know what to do and what to use. Okay, so let's talk about security hotfixes and service pack. Service pack is things in the past, okay? So for the old Windows NT, they used to release different service pack. Why did Microsoft say that it's fixes? Because people don't, it's a marketing strategy. Microsoft said that, well, fixes sound so negative. Nobody wants to buy something new they have to fix. So we're just gonna call it service pack. And then a group of service packs is gonna make one patch. So you would have sometime up to 6 service pack to fix something. That means that when you install the software, you have to install the fixes for it. And so service pack would consist of security fixes and patches. So now when you do your Windows updates, guess what they are? They include fixes, right? They used to be labeled as service pack, but they're not anymore, right? But they are more regularly being released. Back in the day, you have to wait months before you would get it. But now you're able to get more of the updates. So now they call it updates. So that would consist of security fixes, software fixes, debug problems, a lot of the things. And so with that, as most of you are in security, you should always test, right, your fixes and updates before you roll them. You already know Microsoft is notorious for what? Oh, I updated my system yesterday. This stopped working, right? So we want to make sure that we keep track of the version of updates and fixes that we have, and also different type of software, not just OS. And then so you need to test it before you deploy it. So it doesn't mean that my networks would automatically get updates when your system Microsoft updates. We want to roll the updates when it is convenient for the people. Also, it's already been tested, and also it doesn't consume too much bandwidth. So when do they update, you think? In a business, when do they update? Is it every day? Yeah. For most cases, 2 a.m. in the morning, right? So for the night technician that they come in, and if that's their responsibility, they would do the updates. Backup also happens when it is not being used. So you see that a lot. You ever try to log on to web application late at night, early in the morning, right? Sometimes so it's slow because they're running fixes or they're backing up. Okay, Network Plus, like A Plus and Security Plus, they like asking troubleshooting questions. But troubleshooting question can be useful for your interview because they're going to give you a scenario. They're going to say, give me a situation when you come across a network issue. Okay, easy. Oh, my brother could not connect to the wireless network because our router was down, and this is how I fix it. You need to walk them through step by step and be clear. Okay? But they would say, give me a situation, a scenario when you troubleshoot this in a business environment. Easy. You can say, oh, I was in class and my professor was having this problem and I was helping her fix this and I did these things. Okay? Because they want to see if you can logically solve the problem from 1 through 7 or 1 through the end, and you are clear so that way you can walk people through the step. So the first thing, this is the same as A+. You need to identify the problem. Okay? Then you would establish a theory. What's the probable cause? He told me the other day I could not connect to my USB, right? We have to research it a little bit. And I said the probable cause for it, from my theory, is that, oh, it could be that your driver needs update, right? And that means that we have to update chipset or your USB controller. Oh, by the way, I realized why you guys were having issues with the reset for the 40 gig. Because I try to simulate the problem myself. It tells you when you press the reset button to press the reset button the first 60 seconds when it starts. So you have to turn it off, turn it back on, and sometimes you have to do it twice. Then it prompts you with a new password. Some of you did this successfully in your lab, and you created another password and you passed your appliance on to the next person and they couldn't log in, right? And so it was just catch-22. So in the future, if you use the 40 gate, make sure that you press the reset button when it first cycle on. Just hold it down for the first minute and until it prompts you with the new password creation. Okay, so after I establish a theory, I would test it. So I told Jose, I said, go home and try to install chipset driver and USB controller and see if that fixes the problem. Right? Download it and install it. We can also test the theory in other case. And then once you have that, you would establish a plan of action. So if that works, right, we would say, okay, now we fix one system, now we can fix the rest of the system. So we would establish a plan of action and solve the problem. Then we would implement the solution, or in the case that you can't fix that problem, then you need to escalate it, right? Contact the vendor, be able to maybe research and go to your supervisor. And then if it works, then you need to verify that it works. So how do I know if something works? Well, if it's network communication, have the user open the browser and open the internet, right? Access the internet. Because most of the time your trouble ticket's going to come in, oh, I cannot connect to my internet, help me, right? So they will call and say that. And then once you verify that, document your findings. So this 7 steps is the same in A+ as in Network+. So make sure you remember these. And you need to remember this for your final exam. Almost there. Okay. Remember, this is the last unit. 3 chapters. Okay. So if I become a network person, if I become a network technician, an IT technician that's in charge of network, I saw some jobs the other day. Level 2 technician makes as much as some IT man, by the way, right? You just have to have experience and certifications. So you can start with, getting internship and apprenticeship. So if you do this, you need a cabling kit. That means that you need to have an Ethernet tester, coaxial tester, one of the tester, mostly Ethernet. You need to have the stripper, crimper tool. You can buy all-in-one. You need to have a punch down device to be able to have punch down. I didn't show you guys this, but let me see if I can find it. I think I took it out. During break, I'll open the tool property and I'll show you. Also with the fiber. So punch down tool. Compression tool, you all know how to use compression tool with the coaxial cable when you make coaxial cable, right? So that compresses the connector to the cable. Reflectometer, that can be used in the case that if, for other things like electrical related. A multimeter is good, especially to measure electrical signal. Can you buy a multimeter for cheap? I've seen them used for $20-30. But if you buy online, like Amazon, it could go from $50 to higher. So some of these tools are used. Toner and toner probe is for fiber. I've seen like splicing kit that comes with everything and is fairly affordable. But you want industrial splicing kit, which could go up for thousands. So if you work for a communication company, trust me, they're gonna provide you with their quality of splicing kit. But if you want to practice, Amazon sells splicing kit for, it used to be less than $50, but the way the inflation, with the market, it might be a little bit more now. But you can get a fiber splicing kit and try to practice it. And then you already know Wireshark can be used as packet sniffer, but you have other option like, using Ettercap or, T-Sharp. Speed tester. Now you can use an online option, but what happens if I can't get online, right? So make sure that you have a speed tester, and then your system and network integrated polling software, your SNPs. We have to incorporate this with network management protocol, your simple network management protocol, and there are open source tool and there's proprietary tool. Never, okay, listen again, never use pirated software in a business environment. You will get fired on the spot. Okay, especially server licenses like Microsoft, they are serious about that, right? So I had a case long ago, one of my former students got hired, even before graduation. He was really smart, had a lot of experience. First day, they had him upgraded the server, okay? So he tested it, he rolled the upgrade, but he used illegal license. Okay? Because he said that, oh, it's free, I could get it, even for a small business server. And the IT manager found out, he was fired the second day of his job. Okay. It doesn't matter. If you use an open source software for a for-profit organization, you need to make sure you clear that with the vendor. Okay. Because even for school, you have to ask them, right? Contact them and say, I'm using it for this purpose. A lot of times, if it's for educational purposes, they don't care if you download and install it. But if your business is for profit and you're using that software to make money, you have to ask for permission depending on, so look at the license and then contact the vendor. Very important. Okay. So, any question? Okay, that's all she wrote for today and the semester. Okay, so after this, we're gonna work on our lab. I have some drives that if you have grabbed them, copy your virtual machine and extract it to your desktop. Don't run it on the drive. Okay, again, do not run the virtual machine on the drive because you will be here an hour later and ask why is it crashing, right? Because when you start installing services, the drive is not going to handle read and write speed as we want. For next week is Thanksgiving, and I hope you have a wonderful holiday. I will be back the following week, which is the first week of December. I will be here for makeup work. There's no more lecture or lab. Spend that time to work on your practice exam and study for your final. Final exam will be open the second week of December on Monday, and it will close on Thursday. I don't allow late makeup practice exam and late final. Okay, I've had students that have emailed me and asked, right? That's my policy, and I think it's only because it's fair for everybody that takes it on time. Okay. And I need everybody's grade to be uploaded. Some of the students, they need to transfer and they need their grade in their transfer. So I have a deadline that I have to meet, otherwise my dean will let me know. So make sure that we are prepared for the final. And regarding 40B, if you didn't catch it, I will work on that this week and making sure that there's a faculty for the class. We might open the class and not put anybody's name on it until we are for sure, so it will say TBD or something like that. Likely that it's gonna be an online class, it's not 100% guaranteed, because if I cannot find someone, then I have to teach the class. Why don't I teach the class right now? Because I'm already have 5 classes in assignment. We're gonna try to do a late start so that way student can enroll, and it might fill up really quick, as most of you already also are needed. So check for 40B. I will let you know via announcement for this class, but I told others to show. Okay, and then I hope to see some of you in the winter if you're taking programming like Java and Python. If not, I hope to see some of you in the spring. I'm gonna come back to the 41A, 27B, which is at and I have some planning for that class. I was just telling Patricia. I'm planning to do some fake and some good stuff with it. And sorry if you took my 27B last semester, you can always walk the 335. And then, or if you're taking the street structure for computer science, then I was actually no, take that back. Assembly programming, that's no longer. The CIS-40A. That's the plan for now. Schedule might change last minute, and somebody else might be taking some of the lower level classes, but and then 41D, right? I think some of you are in it. All right, so let's stop recording and take attendance because I know some of you have to go to work. Done?
Yeah, thank you so much.
Yeah. Have a good day.
Just look at far.